Howdy everyone. Today we're going to cover Git, how do we use it, what it is, and why it's awesome. So, what is Git? Git is a source revision control tool. Basically, it allows you to keep track of any changes that you make in your code as well as collaborate with your friends and coworkers on like a giant set of code. So, in this class, we're going to be using GitHub. And this is actually one of the repositories that I'm working on for one of my other classes, including all of my code, readmes, and such and such. So I'm going to go ahead and copy this little link over here, which is my clone URL. Basically, it's a link to the repository itself, and let's get going. So I personally like working from command line, but I'm going to show you guys the graphical tool in just a second. So where are we? Oh, got a Git folder. Let's cd over to Git, and see what I have in there. Nothing so far. So before we do anything with Git, we have to configure it to use our basically we have to give our name and email, and that doesn't really make too much sense right now, but it has a very useful property to it. So in Git you have a set of commits, basically changes that you've made along the way that you want to tag with messages. Well, if you're working with one or two people, or if you're working by yourself, and you happen to fail somewhere, you want to know where it failed, and you want to be able to blame whoever did it. So Git gives you that option, and so you know who to blame. You have to tell Git who made the commit. So let's do that. Git config -- global, telling it's going to be within all of the Git parameters, user.name, and then give your name, Michael. And we can also, now we're just going to come over here, basically do the same thing and just do Git email. And then I'm going to go ahead and put my email down, michael.bartling15 plus ta@gmail.com. Come on. There we go. Okay, so now Git is configured to use my username and email. So, how do we use Git? Well, let's go ahead and in the command line, let's open up the manual for Git. There's two ways that we can do this. We can either type git help and see what commands are available. So I'm going to go ahead and do that real fast. Git help. You can see it's got a list of these commands, what you would type in up at the top, and then you can also look at subcommands for each thing. Then the other way that you can figure out what Git is you use Linux man pages. And man pages come with almost every program. So the way you do that is you do just man and then Git. It'll tell you a little bit about Git. So Git apparently is the stupid content tracker. And then it tells you what it really is and how to use it. And then you can exit this by pressing Q. And let's go ahead and open up the graphical tool that I have installed. So I copied this link over here for this URL that I want to clone. I don't need, wrong thing, I don't need to open that. And let's open up our Git GUI. So let's clone this URL. Basically, let's bring all of the code and revisions that we have in our Git remote repository and bring it into our local computer. By the way, you don't actually have to have a GitHub account to use Git. You can use Git within just your computer itself. It doesn't have to connect to a remote. But it's a lot nicer when you have all your stuff on GitHub, because then if you change computers, your code is safe. So let's now select a place where we want to save this. I'm going to go into the Git folder here and hit open, open for some reason. And this is what we have. So let's go ahead and take a look at my current revisions. So these are all the commits that I have so far. I've got my initial commit as well as the code that I have in there. I added a couple more base files, and then I am lazy in my commit summary, so I just wrote updated for some reason. And then I'm going to quickly talk about head master and origin master. Head is telling you where your branch is. Like, that's the most recent revision. Master is what branch you're on. So in this case, we just see one giant line. But you can actually, like from this over here, I can create a branch outwards saying, okay, I want code to branch out to the side, and then I want to have a parallel set of commits that I want to bring back together. And then we have our origin master, which is all the code that's on our our GitHub repository. And you can actually look at these trees and stuff the same way that I'm looking at it over here on GitHub. But most of those branches, a lot of times you might want to create a branch if, say, you want to work on some experimental code on the side, but you don't want it to be released. And then you can bring it back in when it's finally working, so you can merge it into your main branch. But that's one thing. So what are these commits? These commits are just a set of files and tags of things that I've changed over time. And in this case, it's not terribly big. But on some of these other sets, so I'm just going to GitHub, explore. Let's pick up one of the, let's go showcases. Data visualization sounds interesting. Ben Pickles. That sounds fun. 255 commits. So you can see they're tracking all of the changes, little tiny bits that you make over time. So if he happens to break something, he can go back to the one that's working. And then you can also see multiple people are helping on this, and these are the different branches. So he's got one default branch, which is his master that he's working on. And then he's got some extra branches that just haven't been used in a while. So there's the active, all branches, and I know there's a way of viewing them on here, but I can't remember how to do that. Let's just take a here it is. Commits. These are the amount of people that are working on it. Code frequency, network members. I could have sworn there was a giant graph of how it's looking, but let's ignore that. Let's go back over to the important parts of this class. So I'm going to close this diagram view, and then we have this very, very blank screen over here. Well, why is this screen blank? Well, it's easy. We haven't made any changes. So I'm going to go over here, opening up Sublime, and let's open up this folder. So I've got my RTOS Lab 2, and this code. Let's open up something that's scary. Let's open this pll.h. I've got some useless code in here, and I'm going to go ahead and add some crappy changes here that I don't care about. Just hi. And let's go over to this other one. This one looks scary, and I didn't even write this code. I borrowed it from someone else. So see all these numbers, how they're super, super important? This is an E. Now it's an F, and it's going to break something. Okay, so now let's go back over to this and see what our current status is. Refresh it. These are the things that we've modified. And we want to keep track of what we've modified. So we've got our pll.h. It tells us that we've added one thing there. Hi. And in our st7735.c, on this line over here, it's saying that I replaced this line with this line in the code. Okay, and it also tells you what lines these things happen at. So how do we make sure that these changes actually get added? Well, let's try something first. Let's go ahead and create a commit. I did something sketchy. Ultra sketch. And this is just me putting in messages in my commit so I know like roughly what I did. And it's a really good practice to actually keep track of your thoughts in your commit log, because then you know where to go back to when you're finally doing your changes. It makes your overall coding process a little bit easier. So if I try to hit commit as is, it's going to say, wait, there's nothing to commit because I don't have any files that I want to commit. Git allows you, well, I accidentally hit stage and commit, which put all of the files over here in status that needed to be changed into that commit. But suppose I came back over here, and actually no, I'm gonna wait real fast on that. Normally what you would do is you have your list of files over here, you just double click them, and then they'll be staged for your commit. Basically, you're adding it to a list of things that you want to change, and then you create your commit. So let's go and take a look at this graph over here. So now you can see this is where my repository is in GitHub, but this is where I am on my local computer. So you can see I'm ahead of my my GitHub account by 1. So if I wanted to change that, I would have to push to the server rather than commit. Commit is only to your local repository, but when you want to get it to the server, you have to push it to the server. Likewise on the server, if someone else has made a change, you can fetch it to just see what the changes are, and then if you want to merge it and bring all that code over to you, you pull. You do an actual pull request. So let's go ahead and look at this. So this is my updated, and that's where origin master is, and this is where I did something sketchy. Well, suppose I want to revert back because I am an idiot and I did something sketchy. So I found that it's using this tool, it's nice and all, but when you want to revert these commits, it's a little bit more difficult than actually using command line. So let's open up this command line, and if I look at this folder, I've got my RTOS, so I'm going to CD over to that, and these are all the files I have. So how do you use get at command line? Let's just do get help, and it will tell you all the commands that you have, and it's the same sort of thing as using the graphical tool, except now you just say like get add and then the file. So let's do get status, and we can see we're ahead. It actually was what I was saying before. Your branch is ahead of your origin master by 1 commit. You can push it if you want. Otherwise, you have nothing to commit because nothing's been changed. Okay, but let's take a look at our log. We know that something's busted. So get log. This number up here is basically just a reference to this commit. It's an automatic generated number. You don't really have to memorize it or anything. So over here, I did something sketchy, ultra sketch. And in this case, this is the commit that I know is working. Suppose I want to remove all the changes that I made here. So I've got that. Let's go over to here and say get revert, and then I'm going to type in that commit statement. And you don't actually have to put in this whole value. There's other ways around it, but I'm going to go ahead and do that. And you notice that I managed to copy paste there. The way that you do the paste in Linux is you actually do shift insert, just as an FYI, or you can right click and do copy paste, but I like not moving my hand to my mouse if I have to. So what happens here? This is going to open up our commit thing in in Vim. So it wants us to please enter the commit message for your changes, line starting with blank will be ignored, and empty messages aborts the commit. In other words, if you want to if you accidentally type this for some reason, you just do this, and you can comment out the whole thing, and it will no longer revert it, or basically delete all of the lines that are in here. So what we can do instead, I'm going to go ahead and undo that. Just as a quick intro to Vim, there are 2 modes that you have available. Right now, I am in command mode, so if I just try typing stuff, it's going to be really, it might do something really scary, because in command mode, buttons do interesting things. So, like, I can press Control V, and I can select entire lines, or blocks, or I can do Shift V and select whole lines, or, say, for instance, I just want to select a chunk in there, I just hit V itself. But what if I want to type stuff? The way that I do that is I hit I for insert mode. And then now I can start typing things. I accidentally a stupid commit. I am an idiot. So, now we have that. Suppose we want to save it. We hit escape to go back into command mode. Then we type a colon, W to write the file, and Q to quit. And now, as you can see, we went ahead and made our little get revert. So let's go ahead and do get status, see if there's anything there. Okay, nothing else that needs to be added. So let's look at our get log. So what happens here is when we do a revert, it takes this code and it goes through and tries to figure out what this changed and ignores it and makes it a new commit on top. And then that way, when we come over to here, let's see if I can refresh this thing. Okay. That didn't work as well as I expected. There we go. So, revert. I did something sketchy. I accidentally did a stupid commit. I'm an idiot. This reverts that change. And I did something sketchy over here. And then now you can see that it removes this value, and it goes ahead and adds the original one back. So if I come back over to our Sublime text, you can see that that F, here it is, is now back. It's now back to an E, and our PLL.H doesn't have the hi at the top anymore. So that's just the power of Git. So suppose now that I'm actually doing legitimate changes, and I can either write these things from over here. I'm going to go ahead and create a new file. Let's create a new file. Control N and say this is some readme or something. And then I'm going to save that in this folder. Okay, readme. Now it's saved my readme. So if I ls over here, ls, and then readme, you can see the readme file is there. But if I do git status, it says that the readme has not been added. This time, instead of using this tool over here, so now if I hit refresh, it's going to find the readme is untracked. But let me go ahead and show you guys this from command line instead. Just because I like using command line, and it shouldn't be scary. It's really, really nice, and you can do a lot of cool things, like renaming. You can, Linux, for instance, you can rename a bunch of files in your folder. Like in this case, I have st7735 underscore stuff. So I can do like rename -n and st7735 slash, and then awesome. This is what it's going to replace it with. It's going to basically search. S means search and replace. This is going to be what I want to search for. This is going to be the string that I replace it with. And then all I'm going to do is tell it what to look for. So, star for this case. Actually, yeah, let's go ahead and do that. The -n command just says this is what it would rename it as, but it's not going to. So st7735 is going to be renamed as awesome.c. So command line is awesome. But back to Git. So git status. I've got this readme that I want to add. I can git add. It actually tells you right there. Git add the readme will include what needs to be committed to the commit. So git add readme. And then let's go ahead and commit this. So if I look at git status again, it has now been added to the files that with changes that are going to be committed. And you can unstage this if you want. Like if you accidentally put the file in that you don't want to be added to your commit, you just take it out using that little feature that they have there. So let's go ahead and create this commit. Git commit, and let's create a message here. You can either type it without commit like this and git commit, and it'll open up Vim like before, so you can write in your commit here. Or, which if I do this, say since I had an empty message, it didn't commit. So now if I do git commit, or actually if I do, let's say git status, show that it still hasn't been committed, I'm going to do git commit -m for a message if I just want to write it directly from command line, which is what I normally do, and I can say I added a useless readme. So now if we do git status, our readme is there. We don't actually have anything up in our commit. So let's go ahead and look at our diagram again. I really wish that there was a way to just refresh this directly from here. There probably is, but I'm just going to do it manually. So view, graph, I added a useless readme, and it tells me exactly what I changed. And if you have multiple people working on this is great, because you can see over here the author of who did it. In this case, I wrote just Michael in my code. I made all three of these on my this Linux VM, but these are what I've been doing in my office. So I know that I screwed up here. And then you can also, when you look at the commits itself, like in these messages, it tells you who you can email to say, oh, he failed because he's an idiot. In this case, this is diffing with my original account, michael.bartling15ta.com, and this is my dev account that I've been using in my office, michael.bartling15 plus dev. So you know who to call and be like, hey, bro, you screwed up. And then they can make their changes and revert it. So, all in all, Git is awesome. So like these little minor changes, like being able to revert to your previous code is awesome. Like in my senior design class, we spent days, literally 24-hour days basically coding and we've made one tiny little mistake, sort of like I made over here where I changed one number. Changing that one number made all of our code break, and 20 minutes before our final presentation demo, we realized that it broke. So what do? Since we had it in Git, all we had to do was revert to a working commit, which I labeled as working commit. And I just went back to that, and then I submitted that, and we showed it, and it was working. It was awesome, and we got praise. It was the first time that professor has ever said, "Good job," in his life. I've never heard it more than once, but it made me so happy. Okay, so that is a basic introduction to Git and how you can use it. And just as some little tips, when you're doing these commits, I highly recommend that every little change that you make, or not like a single line or 2 lines, but every time you make a small bit of functional changes, go ahead and create a commit. Commits are a lot easier when you have small commits like this, because then you can go back and be like, okay, this is the one that I know I messed up on. I know this one is working, or this part of it is working. And then, assuming you have detailed enough commit messages, in this case, like I actually just created this repository yesterday, so there's not very many commits. But if you have a bigger repository that has hundreds of commits in it, you know exactly which ones are working, and then Git will automatically group some of these commits together when it realizes that they can be. So you can open up this commit group, and they will basically have all of the labels underneath it, and you basically find your sublabel. And then you can search under here for these other things. So that is our basic introduction to Git, why it's awesome, and how you can use it. Let's see if there's any other functions I might want to tell you. Oh, yes. So in this case, I have a useless README. But if I do the standard remove, which is rm, in that file, Git will not know what to do. It doesn't have that file anymore. So what you need to do is actually git remove, and then I can do that README. So now, if I do git status, it says I want to delete that README, ls. If I keep hitting tab, you find that the README is not there. And now let's go ahead and commit this. So git commit -m deleted useless README. Accidentally hit enter, just hit that, and it'll work. Okay, so it deleted the useless README. So git status. Okay, my branch is ahead of origin master by 4 commits. So then if I want to actually push it to the server, so let's see if there's any changes that I have. First, git fetch. No one happened to be working on the code at the same time, so there are no other changes. And then I can just hit git push, and it'll push all of these commits up to the server, and I will see it there. And everyone else who might be connected to that will also see those changes. And then that's how you're going to submit all of your code for the class. You will push it up to the server, and then we will take a look at it. So, but I don't want to do any of that. I don't want to change my important code that I'm going to spend 6 or 8 hours working on today with these useless changes. So, I'm going to go ahead and leave it as is there. Anything else that I saw on here for the Git useful chunks here? I already showed you guys git log, and yeah, let's go ahead and do a git log again. This will just show all the commits that we have. Deleted the useless README, I added a useless README, who was the one who made the change? Me. And you can also get diffs, sort of like this, but when you're doing your diffs, I recommend using this tool. It'll be a lot easier. And that will basically let you see what I changed in the file versus like what it was before. So, all those changes. Anyways, that's all I wanted to cover today. If you guys have any questions, as always, let me know.